Hey scholars, welcome back to chapter 20, where we're looking at chapter 20-2, what are our major water pollution problems in lakes and streams. And so that's what we're going to start with today, looking at freshwater ecosystems, both lentic and lotic bodies of water, and we're going to take a look at what are the major water pollution problems there. We're going to start with streams first, and the streams can cleanse themselves, and they can be very, very good for dilution and dealing with pollution if we don't overload them with pollution. So in a given situation, you could have a little bit of pollution added to a lotic system like a river or a stream, and it can dilute because it's moving water, it can move those particles away from one another, and actually has a lot of it's very biodegradable. There's lots of waste by bacteria it can take some time. So if you overload it with stuff, that degradation part or that decomposition process by bacteria, it does take a little bit of time. So what we see with this usually, if there's a point source pollution going on, we usually see what we call an oxygen sag curve, which is simply the breakdown of biodegradable waste by bacteria. And because the bacteria are using dissolved oxygen to biodegrade or to break down or decompose that waste, it can also lead to a lot less oxygen or dissolved oxygen for other organisms, which is what we call the oxygen sag curve. So let's take a look at a picture of it today. This is the image of it. We have our point source pollution here. And it's obviously deposited there. Above that point source, which is upstream, it's normal clean water. Organisms like trout, perch, bass, mayflies, stoneflies, things that need a higher oxygen parts per million, which in this case it's about 8 parts per million of dissolved oxygen. And your biochemical oxygen demand or the decomposed are really non-existent, or they're really at low levels. So you get these are kind of a more pristine condition. Once you get the point source pollution, at the time of the point source pollution, where that's continuing to be a source of food for bacteria and things, you're going to see a large drop in that oxygen level because of the fact that bacteria are using that oxygen at high levels and high amounts of bacteria in order to break this stuff down. And so what you see here is we call this the decomposition. Now, this is the clean zone above it, right at the point source, right, but behind that is the decomposition zone. And you only see real pollution-tolerant fish living in that region, like carp or gar. Ones that really are not really relying as high on dissolved oxygen. Then you have in the septic zone, kind of where the real big die-off is occurring, where there's lots of anaerobic bacteria, worms, fungi, and sludge. Most fish are absent. Most fish don't even live in that part of the river, the septic zone. And then you have eventually that dissipates, and there's some it's breaking down, so it gets less and less over time. And then your dissolved oxygen starts to go up because there's less and less bacteria doing the breaking down or decomposition, and you start to see pollution-tolerant fish like carp and gar. Again, we're starting to see less biochemical oxygen demand and a little bit more dissolved oxygen. Then we finally get back up to the clean zone again, which is further downstream, hopefully with that dilution going on, and you get normal clean waters, trout, perch, mayfly, bass, and stonefly again. So that's what we call an oxygen sag, because literally the oxygen goes from high to where the point source pollution is, sags a little bit low, and eventually rebounds way further downstream. That's what we call an oxygen sag curve. All right, let's take a look at stream pollution in developed countries. So in a country like the United States, in the 1970s, this helped us out a lot. We had water pollution control laws that were implemented in the 1970s, which had a major help to cleaning up some of our rivers, and one of them being the Cuyahoga River in Ohio. And this says the river was so polluted with flammable chemicals that it actually caught fire several times in the 1950s and 1960s, and it flowed through the U.S. city of Cleveland. A highly publicized photo of this burning river in 1969 actually caused elected officials to enact a law that limited the discharge of industrial waste into that river. And eventually today, as the river is much cleaner. So it used to actually catch on fire. It was that polluted with flammable chemicals. Kind of scary to think about. Another one is the Thames River in Great Britain. This one in the 1950s, it was a little more than a flowing, smelly sewer. After 50 years of efforts and large inputs of money from British taxpayers and private industry, the Thames River has made a remarkable recovery. So that's another success story of 2 success stories about cleanups, and usually caused by an act of government. Contamination of toxic inorganic and organic chemicals by industries and mines. We see a lot of that because we are developed and we have industry. We see a lot of that happening in developed countries. One individual mattered. His name is John Beal. He restored Ham Creek, which is a little creek outside of Seattle, Washington, What he decided to do is he remembered it being very, very pristine when he was younger. It didn't look like that anymore. He planted trees. He persuaded companies to stop dumping near that site. He went ahead and actually came together and removed a bunch of garbage, and now that creek runs clear. Its vegetation has been restored, and actually the salmon have returned to spawn, which is what he remembers best about the handcrafts. Just the individuals matter for our chapter, for chapter 20. Let's take a look at the stream pollution in developing countries. Much worse in developing countries. Over half of the world's 500 rivers are polluted in developing countries. It's polluted by untreated sewage, industrial waste. And if you look at the two major countries this happens to is India. India's rivers, 2/3 of them are polluted, and China's over half. About 2/3 again. China's rivers are polluted as well. So this is kind of a couple of sad pictures looking at a girl sitting on the edge of a road beside a stream located with raw sewage in Iraq. There's also a picture in China here of a highly polluted river in China with all sorts of gross stuff floating down it. Definitely wouldn't want to drink that. And then here's some truck disposing of garbage into rivers in Peru. And we actually used to do this in our own country too. We realized that how harmful that was to the environment, and that the ocean couldn't really deal with all that stuff. And so we definitely banned that in almost all places in the United States. This is a sad, scary story about the Ganges River in India, and it really is an interesting case study because it has a whole bunch of things that factor into why this is a huge problem. Religion, I know that's not the role of the big problem, but it causes human health hazards. But religion, poverty, population growth, and health, all those come together to really make this an interesting case study. And it's on the Ganges River. It's a holy river. There's lots of religious customs associated with that, like praying in the river, bathing in the river, all sorts of stuff. But they also use that for their sewage because they don't really have any good sewage treatment facilities, so they use the river to deal with the sewage. They don't have any crematoriums, or there's not a whole lot of space because India's population is very high to bury people. So they actually use the river to dispose of the bodies as well with human remains. There has been a government intervention with this, and there are now wastewater treatment plants and crematoriums being built, so this doesn't happen nearly as much, but that's still an interesting problem. Added to the pollution problem is that part of their religious customs, they literally throw painted statues into the river as, not sacrifices, but some sort of religious custom. And when they do that, those painted statues, some of them are still lead-based, using lead-based paints and mercury using the paint. So that just adds that more to the water pollution as well. Also, in this area, global warming is happening, which is causing some scary things. The glacier in that region is melting and causing it to actually be seasonal, not only now and in the future, which is kind of a weird thing as well. So here's an image of people praying and gathering and drinking, bathing. It looks like he's drinking in the Ganges River, which again is polluted with all sorts of scary stuff. Low water flow and too little mixing makes lakes vulnerable. So let's take a look at lentic systems now with lakes. Very vulnerable to water pollution. Because they don't have that flowing water, lakes are very less effective in diluting pollutants than streams are. They have those stratified layers, which are basically a warmer layer at the top, cooler on the bottom, with that thermocline in the middle. So there's little vertical mixing or little to no flow, which is very bad for dilution and dealing with water pollution. We already talked about this before, but there's a couple of refreshers for you. Eutrophication is the natural nutrient enrichment. If it's people that are adding to that, and we call that cultural eutrophication, we can see an accelerated nutrient enrichment by human activities, and then one that's perfectly clear and pristine. Low NPP would be a oligotrophic lake with low nutrients and clear waters. All right, so cultural eutrophication is too much of a good thing. During hot weather or droughts, you see algal blooms, increased bacteria like coliform, also more nutrients, and also a lot of anaerobic bacteria. Well, then what happens? We know that a lot of fish die off. We talked about this earlier in this chapter and throughout the semester, and that can cause a lot of problems for organisms to deal with. We also need to try to prevent or reduce cultural eutrophication by removing nitrates and phosphates before they get into the water system. Also, maybe diversion of lake water as well to kind of help with that. Clean up lakes. We need to remove excess weeds. And use herbicides and different algicides to do that. But the downside of that is then you're kind of getting rid of other good plants and things like that too. Some people actually pump air in. Sturgeon City over at Wilson Bay, there are a couple of these. They're aerators basically that pump oxygen to the bottom of the water column to help with furthering the decomposition process, also providing dissolved oxygen for organisms higher up in the water column. Cleaning up is definitely expensive and more energy intensive than prevention. So we always knew that already, but just to jolt your mind with that again. All right, so revisiting Lake Washington and Puget Sound. So we know severe water pollution can be reversed, but it takes a lot. It takes citizen action combined with research and people that are willing to help out on the government side as well. It's good solutions may not work forever. We saw that with as we transfer wastewater from Lake Washington all the way to Puget Sound. Now we see that Puget Sound's having a difficulty. The biggest issue with it is making sure our wastewater treatment plant is working at its best to restore, as the purified water is pure or making more pure or filtered, it's in good condition to actually enter back into a water resource. All right, one of our best case studies, just because I'm from this area, is the pollution in the Great Lakes. In the 1960s, there were many areas with cultural eutrophication, either from factories like Lake Erie, as well as farming with nutrient runoff. In 1972, the United States and Canada actually had a Great Lakes pollution control program. And one of the things that was done with this was, it says they spent more than $20 billion in the Great Lakes Pollution Control Program. And it really helped to decrease algal blooms, increase dissolved oxygen levels, and also increase sport and commercial fishing catches in Lake Erie. It also allowed most of the beaches to actually reopen. So that was the good thing about it. That's what it did as far as helping out clean up Lake Erie. But there's still problems exist. There's still raw sewage in some places being pumped in. There's non-point source runoff from pesticides, fertilizers, a lot of farming in that area. There's a lot of biological pollution, which in this case are invasive species that have been brought in. And we also see atmospheric deposition of pesticides and mercury causing that bioaccumulation and biomagnification in the food chain. So those are still a lot to be done in the Great Lakes as far as that goes. In 2007, there was a State of the Great Lakes report that showed that there are still new pollutants found in the form of toxic polybrominated diethylene ethers used to inflame retardants in various pharmaceutical and personal care products. We found more of those. We saw wetland loss and degradation, and the significance of that is that obviously limits habitat, but it also doesn't help with erosion as well. Declining of some native species like amphibians and some birds, also some trout and things like that. Native carnivorous fish species declining, such as lake trout, and mostly in the Great Lakes. And then they're still thinking about what should be done. As far as the Great Lakes goes, there's a lot that are still working. We need to restore degraded wetlands, deal with the invasive species, clean up the contaminated lake and definitely the tributary system. It's going to cost billions of dollars, but we're going to have to do something about it. And this is just an aerial image of the Great Lakes. You can see the Lake Erie, how green or eutrophic that lake is compared to Lake Superior, which is very pristine and cold, and Lake Huron and Lake Michigan has a lot because of look at where the areas are: Chicago, Grand Rapids, Detroit, Cleveland, Erie. All those areas of big cities, you can see where that eutrophication actually occurs. So we'll pause there for right now. Next time we're going to talk about this one, which is 20-3, looking at groundwater, which is a very, very important thing to us since that's where we get most of our water from. See you guys next time.